Thank you, Russ. Our vendor of the month of May is Richard Rands, a very good friend, a member of our local Friday Night Boomers group, and the owner of Berkshire Valley Models. He'll be going over some of his products and talk a little bit about the art of spin casting. Richard grew up in a rich culture of model railroading, as his dad, Robert Rands, was the founder of Railcraft, which he started in 1964. After Richard graduated from college in 1981, he and his dad started up microengineering. Richard did most of the design and tooling work for the company until about 1997 when he left the company. As a point of interest to this group, Richard designed the point and stub turnouts for the Temelco line of SN3 FlexTrack, which is now owned by PBL. As far as I know, I think that's the first time anyone has tried to produce successfully a built-up stub turnout for a line of FlexTrack. He also designed and produced a line of ON30 FlexTrack. Richard had a brief flirtation with SN3, and then he settled into ON30 when that gauge became popular in the late 90s. Currently, he is constructing a very large ON30 layout, which features floor-to-ceiling mountains in a basement with 10-foot ceilings. The layout features a fascinating collection of very unusual bridges, and Richard has promised to do a clinic for us on those bridges sometime in the future. That said, let me turn it over to Richard.
See if we can get this to work. That work there?
Yep.
Okay, I'm looking at a Zoom join meeting. I'm afraid to, let me put that down. There we go. Richard Rands, Berkshire Valley Models. I am going to talk about a few of our products real quickly, but then talk about white metal casting, which I thought might be more interesting to more people, about how you do the casting, doing the mold making, and the tools and equipment associated with it. I started when we first got going with microengineering. One of the first things we did was buy Durango Press, and Jim Fennell sold us his equipment and mold. So I learned back in the early 80s his technique for mold making, but we'll get to that in a minute. So my cursor does not want to go down there for the slideshow. We'll use that. So in 2013, I bought Berkshire Valley Models, our Berkshire Valley company at the time, which was in Massachusetts. A couple of brothers owned it and decided to retire. They had bought some Chooch urethane kits and along with a bunch of detail parts, and they added on to the urethane kits and also to the parts. And then eventually they bought the Wheelworks line of O-scale vehicles to add to their line, which I now produce. Here, the original line had 3 vehicles, and I've since added on. These are 1934 Ford, I think, AA's. And every so often I find another way of modifying them to come out with another kit. People say, well, how about another another type of vehicle? But if someone wants to do the patterns for it, we could do that. But it's a little over my head. So here's a couple more of them. The high wheel you see there was actually produced by Bill Roy, Mackenzie Iron and Steel. And that ended up going to Anvil Mountain Models when he passed away. And eventually I ended up with Anvil Mountain, but some interesting logging equipment. In 2017, Lowell Ross, who had started Anvil Mountain Models, decided to get out. He had sold off other parts of his business, and he had his laser and a number of HO and O-scale kits, and also wagon line that he had started that he had worked with Bill Roy on, and he decided to get out. So I purchased it and the laser. So have gone back to producing his kits. You can see some of these that we all know in the Silverton area. It was his favorite area, obviously with the Anvil Mountain name. And some of these are O-scales, some are HO, some are both. But he did a beautiful job, and he was a stickler for authenticity on these models. course, this one's still standing, and I guess they rebuilt the tool shed on the one side, haven't done the coal shed yet, but he also had decided to come out with some Rio trucks, something that no one else had produced, 1909. He had patterns made, he did drawings on it, but never introduced them. So it's something I wanted to do. And again, when you take off the, let's get this here. When you take off the seat, there's the motor inside with all the detail that you can't normally see, but he had to have it, but makes for a beautiful kit. He and Bill Roy had made patterns for white metal for a number of wagons and had never produced them. But at one of the narrow gauge conventions, he met Lowell, who had his laser. And so they were working together to produce some of these wagons. Unfortunately, Bill passed away. And when Lowell got it, he produced a couple of wagons before shutting down his shop. And since then, I've been able to expand on those with the basic patterns he had, but then also had new 3D patterns made that I turned into white metal castings to produce more of the wagons you see here. And that also, well, before we get there, here's two of the original ones that he had put out. Also Bill Roy, I think originally Bill Hudson came out with these horses and mules line, and Bill Roy sold them. And these passed on to Lowell, and now, of course, perfect thing to go with the wagons. But I decided to go ahead and expand into the HO market. And again, 3D printed parts that I turned into white metal for the undercarriage, and then laser cut the rest of the upper bodies on most of these wagons. So, and then have expanded into more O-scale structures in the way of these water tanks, a pump house modeled after the Forks Creek. Fairly easy to assemble, white metal, inexpensive, but go together pretty easy. There's one on my layout, dropped in there. And a couple of ore bins that are in both HO and O scale, ore cars and things like that. So that's kind of a brief look at the our line. So I was going to talk about white metal casting. So start with your rubber molds. Now, most of these originated with, I don't know if they came from Chooch, probably some of them did. A number of them are from Jim Fennell's line of white metal O-scale vehicles. And then the others were produced by the Frank and his brother at Berkshire Valley way back when. I have 2 racks of these, so hundreds of parts that are made. And here is the equipment necessary for doing casting work. On the left, you see a vulcanizer that we make the molds in, your melting pot in the middle, and the centrifugal caster. See over here in the corner, anything that turns out bad or after you pick the parts goes in this. And the great thing about it is you get to remelt it. So you don't waste much. You end up with some dross each time you heat up the metal and while casting, but that you get rid of. But otherwise, you're just recycling the same material. Save some money. Of course, you have to have an air compressor for the pressure on the caster. Now, this one's larger than what you'd need. I use it for my laser also, which requires air pressure. So it's better to have a large one so it's not kicking on constantly. And the most important piece of equipment is the blower to take out the fumes from the caster. So one thing you don't want to do is be breathing in fumes from the melting pot. And I use a tin antimony alloy. And but it's something, there's so many different alloys out there depending on what you're casting. So, but get those fumes out of there. So here's the centrifugal caster. The idea is you drop a mold in here, you close the lid, it spins. You have a certain pressure that you set depending on the mold, pour the metal in, and because of the spinning, it throws it out into the parts and fills the cavities then. And again, here's your RPMs down here at the bottom, pressure here. And this is a gas-fired furnace. I work off of propane. If you have natural gas, you can do that. They do have electric ones also. You can see up here on the edge is the dross. Use this strainer to scoop it off, put it on the edge, squish it down to get out any of the good white metal still in there. Then in here it goes, and dispose of it later. But keeps the metal clean and it flows better that way. Here's a vulcanizer, and so this is how you make the molds. We'll start on another shot of it and go to mold making. So there's all sorts of different rubbers out there to use to make this. I like the black organic. Others like the silicone molds. I only tried it a few times, didn't have much luck, but I never gave it much of a chance. But Jim Fennell, who I learned from, used the black organic and have had a lot of luck with it. And they seem to last forever, though. Over time, you do have to replace them as they start to wear out. Here are your rings that the rubber, so there's, I didn't show that, but there's two halves. You drop the bottom in, you put your patterns in it, put the top on, throw it in the vulcanizer, which then turns the rubber from soft into your final rubber for casting. These are locators to make sure the rubber doesn't move on you when you're casting. This is a center ring that, along with this larger piece here that goes up through the hole in the upper piece, so the metal can drop down in here and flow out to your parts, which will be then around the ring. Nope, wrong way. So again, here's the ring, the locators, your knife you'll need, and then screwdrivers for opening up your molds. So here are my submasters. These are for a smoke stack or smoke pipe for HO. Here are some corbels that'll go on some false front buildings that I'm just releasing now. So I'm going to throw these in to make a production mold. These go in that, and I'll end up running enough to get 80 of them out, and then I'll make a new mold of just these parts. So here it is laid out on the bottom rubber, located, all the parts set up. As you'll see, one problem with round parts is if you're not really careful, they do like to move on you. One thing that's important is making sure you have enough of these locators in here to make sure when the pressure's on it, when it's being spun, that the rubber doesn't move a little bit, because that causes you to get poor parting lines. So that requires you modelers to have to, or we modelers to have to do work on them to clean them up. So here's the rings in here with the mold and the vulcanizer. You put it in, pump it up by hand to let the molds warm up and start the rubber flowing in around the parts. And then 300 degrees here for about an hour and a half total. You end up working the pressure up in the first 10 minutes. As the rubber gets hotter and hotter, it'll flow better to fit around the parts, get up to about 1800 degrees. And then you let it sit for an hour and 15 minutes at that. Here's your release. When you're done, you pop it out. Some people like to wait till the mold is totally cold before they open it up. I like to open it up immediately after being done. It's much easier to cut the gates to the parts. So you pop it open, and here's what you end up with. First thing you do actually before opening it is you cut this notch over here to align everything, because if you don't do that, once you open it up, trying to figure out how it goes back together is a pain. Do some cleanup where rubber has gone where you don't want it. Now you can see one of my smoke checks decided to roll a little bit here, but otherwise it looks pretty good. And in fact, that part still fills fine, so not a problem. Then you go and use your knife and cut your gates in. So get them all in, and the idea is to make them large enough to fill the part, but small enough that you can just snap them off with your fingers when you're picking parts, so you don't have to spend the time clipping parts. One thing that a lot of people do, or a lot of molds I've ended up with from people, other companies is they vent. Venting is important because you have air that when you pour the metal in, this thing is full of air and it's got pressure pushing it down. The air gets pushed out to the end of a part and has nowhere to go unless it can leak out to the outside. What it found was, in talking to others in the industry, that, I don't know, someone taught a class on you vent every single part, which isn't necessary, and they love to run them in and then out to the edge. And so if metal gets in there, you end up throwing metal around your centrifugal caster. I found small parts like this, as you can see the size, put just a little one like this, and it allows the air, enough air to push into here that the part fills. Without it, you end up with it stopping maybe in this area. But so venting is something that normally don't even put in until I've run it and to see if there's a problem and then come back and vent. And here's another little part. This is a brake for O-scale wagon, foot brake. And just right here, the air comes out, gets thrown out here, and then it'll fill. One other place you have a problem, even though this is a pretty thick part, are on parts that are down in the mold itself. Where I've had problems with its hub filling, and didn't know what to do about it, and talked to somebody, and they said, take a drill press, put a needle in it, and just drill down slowly with a sewing needle all the way through, and that gives a place then for the air that gets trapped down in that deeper cavity to flow out the bottom, or at least go down in, and you end up with a nice looking part. Now here's a mold from the old Wheelworks line that had been reproduced, not the original Jim Fennell mold, I can tell, because they hand cut their ring here as opposed to using a bought one. But they filled on this side and then they vented out here. The idea being the metal gets thrown out to this end and then comes back, forcing the air into this corner, which is a good idea, except on a part this thick, you don't need to do that. In fact, I ended up with problems of it not filling in this corner. And the easiest thing was just to put another gate in here and the part fills 100% of the time. Problem is, because this is already cut in here, I end up throwing metal all over my caster nearly every time I cast, but that wipe it off, throw it in the pot, melt it down again. And here's a mold somebody decided to go for quantity over quality. So these are oiled cans in O-scale. It's probably about 100 of them, and they look, hey, I'll turn out 100. You don't have to, I think there's 12 in a package, so you can do a lot of packages at one time. Problem is, with this many and no locators in the middle between them, you end up with either parts not filling properly or bad parting lines around them. So you end up rejecting at least half of these, where if they would have gone with half of them in a little closer, not out at the edge where you get flashing, a few more locators, they would have gotten 50 out of 50. But it's all about what you're looking for and who's doing it. Here's one that I may have originated with Bill Hudson or Bill Roy. Now, boy, they love their locator rings, but they didn't have the center ring. I guess they didn't own one. And everything aligns nicely, but when you pour the metal in, because you don't have any place for the excess to go, either you end up pouring it short or you have metal backing out your hole here, which can become a real problem if it gets up into your the top ring that goes on your mold. So better to have that center area, easier to control the amount of metal you're pouring in there, have room for air. So the casting process. So you made a mold, now you're ready to cast it. Have a list of hundreds of molds, and any new molds I make, I can pretty much run at 20 pounds pressure, and RPMs is a ratio based on the caster, and between 50 to 60 pound, not pounds pressure, RPMs on it. And they normally will turn out well. Smaller parts, you may need to turn it up a little bit and a little less pressure, but they're pretty uniform. Some of these molds are 40 years old, and you can see the variety of different pressures and temperatures, not pressures, pressure and RPMs. But you also, depending on the thickness of the part, may vary your temperature, 500 for thicker parts to 600 degrees for thin parts to get them to fill. And here's the caster. Metal looks a little dirty there, but you can see the dross over here. Use the strainer, clean this off, put it up here. After you've gotten what good white metal will drain back in here, into this it goes to be disposed of. So here's our ladle for pouring. And here's the mold going in. You can see little excess around the outside as you open it up, throw those over there, and eventually clean that out. Into the pot it goes. Here's the top ring that'll drop down in here. The notch over here fits in, 4 of them underneath here, that holds everything in place. When the pressure comes down and it starts spinning, you pour the metal through here and it goes down in and it gets thrown out into the parts. Pressure gauge running at 25 pounds there. And then this is at 65 to 70%. I don't know what the RPMs are, but don't worry about it. I just use this for my judge of how much I need. And here's that mold after casting it. You can see pretty much 100% came out. I got a little flashing down here, and that one part right next to each other that still will pop off without any problem. And my the big thing, I'm getting the flashing because I needed these corbels to come out, which are thinner. Once I got out the ones I needed, I don't have to worry about them anymore. I can turn the pressure up a little bit and not get the flashing. Another way you can solve that problem is by, you can see it in the next one here, using tape, because your vulcanizer is not going to be always accurate at making the mold the same thickness all the way around. So you'll end up with spots where it'll flash, where others won't flash. You turn it up, then these don't fill, and these are fine. Just put some masking tape on them to apply a little more pressure in those areas, and you can take care of the problem. So when I cast, I run 4 molds at one time. So one goes into the caster, pour the metal, push these down, open the last one up, pull out the parts. Of course, wearing gloves. I didn't show pictures of the gloves. You want some good gloves. Put it in your pile, then open up your lid on your caster, pull that mold out, set it on the table. This one goes in and pour. So these are slowly curing as you go. If you don't let them cure, they will fall apart on you and you won't have these, you'll end up picking parts out of your mold. But by doing this, you end up with these nice rings. And then from there, you send them off to the boss, who takes their time picking the part, inspecting and picking the parts. And here are seats for the Ford trucks, and make sure they fill properly. And if done, they're easy to snap off with your fingers. Go into the bin here for meltdown. And again, here's that roof where I added the extra gate in here to fill, and in they go. So that's the art of casting from my viewpoint. Everyone slightly different, but seems to work. So that'll do it. Hope you enjoyed it.
Hey, thank you, Richard. That was great. If you have any questions, please post them in the chat room, and let me run down some of the questions we have. Also, take note of the last sentence on the slide that Rich is showing right now, when he has a video that'll be shown when this briefing gets posted on YouTube. Steve Hollenbach said, are all your models in a variety of the popular scales?
Very few in S. Actually, you can use some of the O scale detail parts will work in S. I know that because Don Heimberger used to buy my parts and sell them to you guys. But, so it's mainly HO and O scale as far as buildings, vehicles, wagons, but some of the detail parts can be used in S.
Okay, does the Iowa, let's see, Greg Wright says, does the Iowa Tiger tram house come in O scale, and does it have an interior, or at least an interior equipment drawings?
No, on both of them. They're only done, it's only done in HO, and Lowell didn't go into what all the interior was, but in O scale, it would be a huge kit. That was a very big building in HO. Okay,
Reiner asks, how many parts can you produce at the same time in parallel? I'm not sure I understand in parallel.
You talk white metal casting?
Apparently.
So he made, before you saw it, so I'd normally use 4 molds at a time. And between taking the mold, putting it in the caster, pouring the metal, opening up the last one in that row, pulling the part out, and then having
I
the
understood.
Okay, yeah, I got it, 4 at a time. Okay, yeah. Let's see, Chuck Graham says, great presentation, really interested in how you make molds. I guess that's it. Good. Well, thank you very much, Richard. That was a great presentation. Russ, back to you.